Floyd, what have you done in planning for the descent and touchdown in Apollo 12 that is different from Apollo 11? This, of course, indirectly asks you, what did you learn from 11, and how are you incorporating it in planning for the Apollo 12 lunar landing mission?
Okay, the basic design of the descent, of course, is the same as in 12. We have still a three-phase type descent. Braking, the early part of it, 8 minutes worth, is efficiency and reducing the velocity. The approach phase, where the crew is seeing out the window of the landing area for the first time, is also in essence the same. The one part that is different is the landing phase from an altitude of about 500 feet to touchdown. In this phase, we design it for crew constraints and capability of manual control in flying the vehicle.
But you had manual control before.
Right, and we had designed the trajectory before to be at somewhat lower velocities than what we were designing for this time. At 500 feet, we were going at about 60 feet per second, about 40 miles per hour at 500 foot altitude on Apollo 11. On 12, we speeded that up to 80 feet per second. And this enables the crew to have better coverage of the terrain area, enhances their ability to move over the surface since you're going slightly faster, and in no way takes away from their ability to control the spacecraft.
For jet pilots like Pete Conrad and Al Bean, it gives them somewhat of a closer impression of the approach of an airplane, doesn't it?
Possibly. It's still pretty slow compared to those types of speeds, but going over the lunar surface at these speeds, it's still fast enough. You don't want to go too fast so that you can assess the area below you and just ahead of you, looking for a good spot to land.
But you are still moving across the landscape faster in making your approach.
That's right. That's right. And this gives you more maneuverability down low. And a secondary objective on this flight is to try and land as close to Surveyor III as possible. This enhances that objective.
That pinpoint landing objective.
Right. This is not where we're trying to start the pinpoint, but this will help you with more maneuverability throughout the visibility phase.
Now, it's my understanding that in descending a little faster down to an area near the surface, this, in effect, will give Apollo 12 a bit more fuel or descent time there in the final landing phase.
Yes, about 10 to 20 seconds more. That doesn't sound like much, but every bit helps.
That means Pete will have more time to maneuver around for the actual spot on which he touches?
Slightly more, yes.
We've heard him mention Pete's Park, that spot where he hopes to park the lunar module. He came up with that himself, I think, didn't he?
Yes, he did.
Has that caught on with the rest of the engineers supporting him?
I don't know.
Okay, now in getting them down to this point, what do you in landing analysis do in preparing the material or the actual trajectory? What do you do in telling them where to go and what to do to touch down in a pinpoint position?
You mean it's... Your job. Well, we have to plan the trajectories to be compatible with the systems that are being operated during this time, during the descent. Like the descent engine, there are certain constraints that you have to operate within, the landing radar, the guidance system itself, and there are crew constraints on flying and designing the trajectory as well, and you have to integrate all these together and still have a flexible design to cover the dispersions that can crop up in any one of the systems.
Well, in effect, is this the preparation of mathematical procedures or charts that the flight controllers, the guidance officers, and the flight dynamics officers will follow in the actual conduct of the mission? Is that what it is?
Yes, we participate in meetings throughout the center with all the various elements involved, crew support, flight control, the engineering development directorate, the program office, such that we come up with procedures compatible with carrying out the job, and we develop the charts and suggest what displays in the control center would be valid for monitoring during the burn and this nature.
You prepare it and say, okay, now fly it like this, and you can do it. Is that a simplified way of saying it?
Yes, and there's a lot of people involved in saying that, right. We're one of the elements.
Okay, thanks very much. Floyd Bennett, Chief of the Landing Analysis Branch at the Manned Spacecraft Center. This is Rhett Turner. Floyd, one of the secondary missions, but one which has taken a lot of planning time by people in your department, has been that of achieving a pinpoint landing on Apollo 12 and possibly to land near enough to Surveyor 3 that astronauts Conrad and Bean may walk over to it. How did you go about working out this technique?
Well, we have to start in the lunar orbit with our knowledge of how well do we know where the spacecraft is, because the guidance system is going to work with this information to try and go to the particular point where we think the Surveyor is. You take landmark sightings on it from orbit and try to establish your position, and then we fly a descent. We fly it on paper. We fly hundreds of cases and assume systems variations, uncertainties in where we are, and come out with our best estimate of how close we'll land to the Surveyor. Now, we then take this and see how much the crew has to change its position once it sees where he's going, from an altitude of about 7,000 feet down to the surface. He has the capability to maneuver the spacecraft several thousand feet, up to about 4,000 feet. This takes a certain amount of fuel. He has this capability. So we have to get our dispersions down on that order of magnitude before he has a chance of getting to the Surveyor.
Get the dispersions down, the possible fluctuations of his track from right, left, downrange, uprange, altitude, and so forth.
Right, that's right. Now, if we have an error in our position, as we had on Apollo 11, on the order of 20,000 feet, we have the capability of reducing that down to 3,000 or 4,000 feet by changing our estimate of where the landing site is some 2 minutes into the descent burn, very early in the burn.
That's something we've been hearing a good bit about, and that is the updating of the track after the burn begins.
Right. You have the capability to make such a large correction there cheaply, since you are very early in the burn, and you have a chance then to adjust where you're going. Whereas if you try to do this later in the burn, it becomes very inefficient, because you're only trying to go some 20,000 feet then. If you change it 20, it really costs you at that time.
Now, the finding of Surveyor, as we said, has been designated as a secondary mission, but just the actual development of pinpoint landing techniques, of course, is very important for future flights, isn't it?
Yes, it is, because the scientists want to get into a 1 kilometer radius area to find a scientific site of interest. So this is plus or minus 3,000 feet in all directions, and so we have to develop that capability. And this is, if we can demonstrate that on this flight, then we would have moved far in that direction. But again, it is a secondary objective. The main one is to get the man down safely and back home again.
Let me ask you sort of a side and personal question here. You are all engineers and mathematicians. Have you figured out what the odds are on getting into that area called Pete's Park?
Well, mathematically, we can say we have the propellant and the capability on a 99% basis. But now there are a lot of assumptions that go into that, and we never have tried this update capability early in the descent yet. So there can always be a surprise, and I think it's well over 50% though.
You've given me an analyst's answer rather than a gambler's, Floyd.
That's right.
I'm not. Good luck. Good luck. I hope you're 99% right and a lot better than 50. We'll see.
Thank you.
Floyd Bennett, Chief of the Landing Analysis Branch at the Mission Control Center. This is Rhett Turner.